So we want to use the Raspberry Pi device as an IoT device. That's most common for the purposes of this course anyway. That's what we want. And now Raspberry Pi, remember, doesn't have to be used as an IoT device. Raspberry Pi can be used as a laptop, desktop, a substitute for such a thing. It might be a slow substitute, but you could use it that way. You just plug in the HDMI, plug in the monitor into HDMI, plug in keyboard and mouse into USB, and it'll act like a laptop. But we're going to use it as an IoT device. So we're going to use it, what that means is we're going to use it inside some bigger system, and we'll use it to control other devices, observe other devices. So we'll connect to sensors and actuators. It'll receive data from sensors, output commands to actuators. So when you're using it like that, programming is needed. Notice that if you use it as a laptop, desktop, you don't have to program, right? You can sit there and just like you would with any laptop, run applications on it and so forth, and you don't have to write code. But when you want to use it as an IoT device, you need to write code because the code basically is telling it what to do. You don't want the user directly interfacing with the device, telling it how to work step by step. You want to have a bunch of code there that just runs and does what it's supposed to do. So you need programming. So that's what we're going to do. So what language can you program in? Well, with the Raspberry Pi, it's a microcontroller, and you have many choices. It's a microcontroller with an operating system. So you have many choices as to what type of programming environment you want to use. You can use really any language that you can find the appropriate compiler or interpreter for. So for instance, C, C++, Java, these are all compiled. Well, Java's in between. You need an interpreter for Java too. But C, C++, anything like that, you can compile it as long as you have a C compiler, C++ compiler. And that exists for Raspberry Pi, and you can use that. Cross-compiler maybe, or you can compile it directly on the machine. That's fine too. So you can do that. You can also use an interpreted language or a scripting language like Java, which is interpreted with the Java Virtual Machine, Python, Perl, any of these type of languages where there's some type of an interpreter that translates the code. As long as you have an interpreter for Raspberry Pi, you can use those languages too. So you have a lot of choice. We are going to use Python. Python is the best supported language for Raspberry Pi. Now, say best supported, you can use any language you want, but Python is it's the most popular and best supported for Raspberry Pi. And when I say best supported, there's a good programming environment. There are good programming environments for a lot of languages, but Python, there are a lot of good APIs for Python on Raspberry Pi. API meaning Application Programming Interface, basically library functions that are convenient, that do things that you want. So Python is the language that we're going to use on the Raspberry Pi. So we got to learn a little bit about Python, and so this module is really about Python. Learning the basics of Python so that you can use it comfortably when you're programming your Raspberry Pi. So Python is a high-level language. High-level means it's basically, roughly means that it's easy to use. The details are hidden from the programmer. Some details are hidden from the programmer. So there are a lot of details in Python that are hidden from the programmer. The programmer does not have to see. For instance, in Python, you don't have to explicitly declare data types. You don't have to say this variable, say you got a variable x, you don't have to say integer or car or float or whatever it is. You don't have to say that, which by the way in C, like with an Arduino, we had to say that. We had to specify, oh, int x. Right? With Python, you don't have to do that. It takes care of that itself. It basically looks at the interpreter on the fly, can see how the variable is being used, and then casts it accordingly. So it says, oh, this is being used in an integer, I'll call this an integer, and so forth. So things like that. No pointers. Now, we haven't talked about pointers, but pointers are basically pointers to addresses in memory. C, C++ support these, but those are hidden from you in Python. It's object-oriented. Python is object-oriented, meaning it has classes. Now, we haven't gone into classes and really what they're about. We sort of touched on it with Arduino. There are classes, but take my word for it, it's a useful feature. And you don't get it in, say, C. In C++ you do get it, but in C you don't get it. So Python has a lot of these features that make it really nice to use, and I use it a lot for various programming assignments. Now, it has disadvantages. It is slow. That's the biggest disadvantage. It is slow compared to C, C++. It's slow compared to a compiled language in general because the interpretation process takes time. Excuse me. It takes a certain amount of time. So compilation is, once you've compiled it, you don't have to convert it again into machine code, so it's quicker to run C, C++. So also, one thing that's related to that is that Python is very hard to get to meet real-time deadlines. So this comes up in more sophisticated IoT devices. We're not building devices like that right now, but where you have to meet deadlines. So this has to be done. A certain task needs to be complete within this time, precisely in a certain deadline. That's much easier to accomplish in C than it is in Python. The reason why is because the Python interpreter itself, which is running and converting the instructions while you're executing the code, that interpreter takes time. And that time is a little hard to predict. So when you try to meet deadlines, you have to also consider the interpreter's delay and things like this. And you don't know exactly how the interpreter is going to convert the code a priori. So you don't know if it'll convert in a fast way or slow way. So it gets difficult to meet real-time deadlines with Python. But we are not, that is not our goal here. We're just trying to use it in a reasonable way. So with Python, there are roughly two versions. I say roughly, broadly two versions. Now there are refinements on these versions. There's Python 2 and Python 3. You know, there's 2.2, 2.3, 2.4, and so on. They're basically, I think on 2, they're in 2.7 something. And then there's Python 3. 3.43 is the last one I think I remember using, but they're somewhere up there. So it's Python 2, Python 3. Python 2 and 3, they're both supported. So even though Python 3 exists, they haven't gotten rid of Python 2 support because there's a lot of old code out there, a lot of open source software that relies, it's written in Python 2 and assumes Python 2. So they're both supported. And actually both of them will be present on your Raspberry Pi. We're going to use Python 3. Now, there are small differences in syntax, specifically like print statements. Okay, print statements are done differently, or the syntax is different in Python 2 than in Python 3. There are a few other little things that'll confuse. So we're just going to stick with Python 3 throughout this course. It's probably the best. If you're programming new stuff in Python, you probably want to go with Python 3, because one day, I suppose, Python 2's got to get phased out. So, thank you.